this is going to help us understand a classic case in using specific heat. First thing I'm going to do is I'm going to take a piece of iron, and the question is, I don't know what the specific heat of this metal is. We're going to heat it up to a certain temperature, but before I do that, we're going to look at the energy it contains. We're going to put a thermometer on that, so we'll get a change in we'll get a temperature, and we're going to put it in the water. Now, here's the really cool part about the water. I know a lot about the water. I happen to know that it, for instance, has energy. I know the volume, the mass, and I know the specific heat of the water, and I can measure the change in temperature. I can find the energy going into the cold water. Over here, I can get the mass of the iron. I can get the temperature of the iron. I'm going to put it into the water. The energy flows from hotter to colder. And when that happens, heat this up. So when that happens, we can use the equation to figure out what's going on. So let's get this nice and hot. And this is going to show a model of so it's containing energy, heat energy. It's got that Q, the symbol Q. I'm going to grab it, take the hot metal, put it into the cold water. Hopefully, there we go. And watch what happens. The metal cools down, the water warms up, and notice that there's less energy contained in there. That turns out to be key. Okay, so here's what we got going on. Here's the cool part. Here's the iron. It is super hot. You can see the energy inside the iron. You can see the temperature. The iron has a mass. The iron has a specific heat. And because I'm going to take that iron and dump it into the cold water, okay, we're going to see a change in temperature now. And that's going to equal Q. Okay, that Q is flowing energy. It has to flow somewhere. It's going to flow into the water. What's going to happen to the water? Guess what? The water also has a mass. This is the mass of the water. Here's the water. Okay. It has a specific heat, which is very well known. And because the hot metal is going into the cold water, the temperature is going to go up. It's going to have a change in temperature. Now, typically what happens is I can figure out the mass of a metal. Okay, I'll know the mass of the metal. I can figure out the change in temperature of the metal when I do this. I know the mass of the water. I know the specific heat of the water. I know the change in temperature of the water. The key here is if I can find the specific heat of a metal, I can then start to say, okay, I can identify what metal it is, and I can find a property of that metal. That's where this comes into play.